Welcome all, and we'll start, if that's okay with you guys, with Lynn telling us a little bit about the applications of this technology.
Thank you. So I think one of the things that I hear often about 5G is we have 4G, and I've been in the wireless network industry for longer than I would care to say. And every generation, there's always this question around, why do we need the next speed upgrade? Why do we need the next latency shift? And I think one of the things that's important to understand about 5G is it is a very, very unique standard as far as wireless technologies go. There are 3 use cases. Normally, all of the use cases for wireless technology have been oriented around the smartphone and mobility. And with 5G, there was a recognition that having a one-size-fits-all network with one kind of connectivity is really not what the world and the industries need in the future. So there's an additional 2 use cases that were designed in by the ITU. Massive machine-to-machine is one of those, and then ultra-reliable low latency, which includes a high quality of service. And I know Christian will be talking about some of his use cases for that. So you have the ability to customize the way that the network operates and tune it for a very specific set of business conditions. This wasn't possible in the past. And so think about it, you wouldn't put an 8-way highway through a town of 20,000 people. But you might need that for one of the tier 1 cities in China. And this gives you the ability for a different kind of transport, for data transport, to be tuned for the needs of the business that you're going to be addressing at the time.
So one quick follow-up to that. If you're not a Verizon, do you need to worry about 5G if you're not a provider?
I would think 5G is one of those areas that's an opportunity for every business to take a look at for more customized private networks, for more customized industrial applications. So yes, you do absolutely want to work with the carriers because they will be having great coverage. But there's so many more opportunities than just what a wireless communications provider would give you to sell for your employees to be available on their smartphones.
Okay, great. And so now we'll move on to Christian. Tell us a little bit about Skycatch. What's exactly involved and how you believe you'll be able to harness this technology to really improve what you're able to offer?
Thank you. Thanks for having me. Skycatch works with really large construction, mining, and inspection companies, and it helps them visualize the physical world so they can make decisions on whether you're coordinating things for the week, whether you're looking for damage on your infrastructure, or whether you're planning extraction materials on a mine. So having visibility on a site is extremely critical. So today, we gather that data using drones. We have several devices that we use in order for us to achieve accuracy. Being able to send that data to the customer really quickly, however, makes a huge difference when it comes to safety, when it comes to making decisions very fast. So that's where 5G is going to make a huge difference, being able to send the data very quickly.
That's great. And you've already had a very solid working partnership, and that's perhaps a good example, too, right, of the innovation at play.
Absolutely, yeah. We have a partnership with several companies, NVIDIA, DJI, Komatsu from Japan. And what's interesting about that relationship, the last one with Komatsu, is that they're using this technology to enable automation of machines. Being able to automate machines, keep them completely autonomous. But not only that, most infrastructure, most companies out there who want to automate things and want to use AI or machine learning, they don't have data to train on to make devices smart. Having access to 5G will enable these companies to send data to the cloud so that they can start training the models so that they can enable AI into their platform, to their deployments.
So we'll move on next to Eric. And you brought up such a good point when we spoke previously that this is a transformative technology coming at a transformative time. Maybe if you could expand on that.
Sure, I'd be happy to. So, when I think about 5G, I think about the same 3 implications that Lynn cited earlier. It's very easy to think of it through the same lens that we always think about the wireless network, which is our phone And I was struck by the comment that you made at the opening about whether you're here in the room, and thank you all for coming this morning, or watching on your phones. In the not too distant future, that's going to feel like the same thing. We look at an industry like media that's going to transform into a nearly $500 billion industry over the next 10 years. And the impact of 75 to 90% of mobile data consumption is going to be video. The speed and capability of 5G is going to enable immersive experiences where being in the room and watching on your phone will be very, very similar experiences. So the implications for mobile advertising and marketing, gaming, even our business, at SAP, when we try and demonstrate the power of our business applications, we have created these immersive theaters, and the ultra-low latency and resiliency of 5G allows an almost there experience that has implications for everything from on-the-job training for dangerous or difficult situations like complex assembly or nuclear, to the use of robotics in manufacturing. It's those other two that really come at a transformative time. Every industry on the planet's been disrupted over the past couple of years, whether you are a consumer goods manufacturer that now needs to be a direct-to-consumer retailer, whether you've seen your business model upended as has happened significantly in the media industry. What we see is every industry on the planet is transforming. And when you look at the constant data stream and data proliferation of massive IoT, or the critical low latency of critical IoT, that coming at the same time as industries transforming means the technology is caught up with the intent. And so the ability to use 3D visualization in healthcare, the ability to, with the assistance of drones, identify capital assets within a range of 2 to 3 inches, having this technology available at the edge where computational power hadn't formally been available, even though the sensors were there, the computational power wasn't there, is going to be transformative to a lot of these digital transformations we see companies embarking on right now. And so if you operate a physical asset intensive industry, if the use of 3D visualization, robotics, or video would aid performance in the industry, or if you manage a complex supply chain, then you can't possibly understate the impact of 5G on industry.
So you've addressed some really important issues, healthcare, some applications that will really change lives. Just going to retail and the idea of shopping, you also gave me an example of if you're shopping for jeans, say, this is an opportunity to actually see what you look like in the jeans. So, it's truly a complete spectrum of applications. Maybe you could talk a little bit more about like the kind of the nitty-gritty when it gets down to the rubber meeting the road.
Sure, and I'm going to go back to healthcare simply because you mentioned it, because there were 2 scientists who just recently published cancer research that is highly dependent on the availability of 5G computing to push that level of computational power out at the edge. What they can do is they can take a 2D image like a CAT scan or an MRI, re-render it as a 3D image, because 3 dimensions dramatically alters our perception of the physical world, and it's created tremendous leaps in cancer research as a result. And so then you then start applying that to the use of video consumption or robotics in the workplace, and you begin to see what that could mean for product development, assembly manufacturing, the movement of goods through the supply chain, the monitoring of temperature and cold storage for pharmaceuticals. If you can do what 5G is capable of down to a network slice, which is a new capability of 5G networks, then you can actually manage the bandwidth availability and the latency in such a way that it opens up new worlds of computing for the workplace.
Yeah, just to riff on what Eric was talking about, I think if you could pull it down to a crisp little pithy bullet point, 5G is the merger of communications and computing. And it makes computing accessible in places that it used to only be connectivity. And so the intelligence and the computing power that's becoming distributed is one of those raw tools that can be applicable to any industry that is going through transformation, which is every industry that we know of.
We talked a little bit about some of the applications for businesses. So I'm thinking about if I'm a member, an enterprise, and I'm listening, boy, it sounds great. I'm in. What now? What's next? And Christian, you've certainly embraced it. You've embraced lots of technologies. What would you say to somebody who's kind of sitting on the sidelines? Is this going to be the new math? Do I really have to learn this?
I think, yeah, I mean, everyone is familiar with the cloud. We've leaned on the cloud to do a lot of processing. We know the cloud is connected to broadband. Latency is non-existent. The servers have connectivity. So all your APIs, all your processing happens in the cloud. We've been trying for the last couple of years to do the same thing on the edge. IoT devices are doing a lot of processing these days, but it's not connected to anything. Sometimes you're connected to Wi-Fi, sometimes you're connected to LTE, 4G, but you don't have the reliability and access that you have in the cloud. So this is basically giving the IoT devices, treating them as servers almost, just the same way that we treat the cloud, giving them access to connectivity.
I think there's an important point buried in there about bandwidth management, sort of in the sense that everything old is new again. You know, if you were a CIO in the 90s, you thought about multiple priority label setting, tagging, right? What you had to throw on the floor and ignore when the network availability was low. I think 5G changes that equation for the good, because you're going to have some IoT scenarios that are not mission critical from a data sensitivity perspective. It's just a constant stream of data. You're going to have others like autonomous driving or the use of robotics in healthcare, where you're going to need continuous low latency for certain applications at certain periods of time. And because they're mission critical, having an ITR, a network architecture that is now application aware, is going to change the way IT departments think about the network. And so I'm fascinated by how we're revisiting that whole concept of network-aware applications and application-aware networks, because we will have to reprioritize what gets to consume bandwidth and latency in our network. And I'll just give you a quick example to highlight the point. Autonomous driving. Autonomous driving is predicted to change about 3.5 million commercial driving jobs. The biggest concern is security, right? The Google car crashes and everybody sort of freaks out, and autonomous driving is not coming. Autonomous driving is coming. Specifically and especially in an enterprise context, but the low latency that's available over a 5G network, once it becomes proliferated, could increase stopping distance by 4 to 5 seconds, which is the difference between commercial driving at 25 miles an hour and commercial driving at 65 miles an hour.
You brought up security, and I can't help but wonder, I know we need to trust the cloud, but in this environment in which we face of, I mentioned, systems getting hacked. I've heard you guys talk about how 5G is actually more secure. Could you explain that? How is that the case?
I'm the engineer in the group. Guess who gets it? So I think that there are aspects of all of these systems that we're talking about. You know, one of the examples Christian was talking about, the cloud, and it used to be that people and CIOs in particular would look at that and say, I'm not so sure about data security and sovereignty. And what's really fascinating is a lot of these systems that are hosting these applications are more secure than what you would see as the analogous system, because there's a lot of work that goes into making it a little bit more unique under the interfaces that you would be putting your applications on. And that inherently makes it safer. With 5G, when you look at the different frequencies, the different spectrums, the different licenses, the way that you can interact with what's called unlicensed spectrum, for those of you who are not wireless people, that would be Wi-Fi is a great example of unlicensed spectrum. And you get a flexibility in terms of being able to set up what Eric referred to as a network slice, you don't end up having to have the entire channel. You can have custom channels to the needs of the application, which brings in opportunities for more private networking and more encoding standards that would be end-to-end.
So it's more specific, it's closer to you?
Yes.
All of those
More
things.
custom for the needs
More
of the
custom.
application. One of the big barriers for being able to do wireless IoT has been the fact that the communications channels are not something that you can break down to match the needs of the application. So you either fill the whole channel or you have to figure out a way to monetize the whole channel. And that becomes really difficult when you have low-level communications. You don't have a lot of bandwidth. And so those customizations, being able to program the network for the needs of the time, make it a lot more secure, because one of the concepts in security would be attack surfaces. This makes it more unique and less general.
Interesting, because I think that also introduces a new level of security that you have to worry about. Although you're isolated away from, in our case, we no longer have to connect to the Wi-Fi. And Wi-Fi, in many cases, is vulnerable. But in some other cases, you could potentially have someone hack the IoT device and put their own card on it and send the data someplace else. The IoT devices that we're looking at today, ourselves in our company, we are not really spending a lot of time looking at all the levels of security that we put on the cloud. We're starting, and a lot of companies are starting to do that as well. But it's definitely an area where IoT devices are going to have to start thinking about the same way we're implementing security for cloud. Same way we need to start thinking about implementing security, not necessarily on the communications portion of it, because that's secure, but how people are able to
Access the data?
access the device itself. Yeah.
Yeah, to the point you have more compute power, which allows you to have more computational capabilities, and that changes the nature of the game.
Because now you have, the cloud is, you've been to a server, it's completely secure. Sometimes you have to go through many layers of security. The device is exposed, it's out there. And you don't know yet if you have access to a lot more data from the cloud into that device. So these are some of the things a lot of companies need to start thinking about.
So we have about 6 more minutes. I wanted to talk about the physical infrastructure that needs to happen for these kinds of capabilities. So whoever wants to grab it to talk about. I understand fiber needs to be laid. There's some specific things that need to happen for 5G to get off the ground.
I can talk about the things that you don't have to rely on anymore. For instance, for drones specifically, you have to rely on radio frequency to send data back and forth. That's a very old technology. With 5G and low latency, you no longer have to lean on radio frequency anymore. You can have this drone or this device flying really far away without having to be connected to a radio control. You can just connect directly to the 5G network. These are some of the things, enhancements that will remove a lot of the infrastructure that existed before. So it's going to make things a lot easier. I'm not sure about the infrastructure additional infrastructure that will be needed in order to enable 5G.
There are a lot of differences worldwide that I've seen. I listed 3 different use cases for 5G. And in engaging with a lot of the operators worldwide, you'll find differences based on what industries they're serving, but also the use that is popular in that region. So a good example in the US and sometimes in Europe, you'll have a challenge with being able to get dense urban areas covered quickly, because if you're trying to lay down fiber, what ends up happening with fiber is a challenge with being able to actually get access, dig up the streets or lay the fiber down, whereas fixed wireless would be something that you could actually look at for high bandwidth applications. And so that just solves a problem right off the bat. You don't have to worry about permits to dig anything up. So that's one use case that you would see. And it's just an infrastructure solution that has been a nagging challenge in the industry for a while in terms of being able to lay that down. So that last mile problem becomes a lot easier. There's other industries that if you look in China, for example, there's a lot of one belt, one road, and a lot of the shipping and the containerization that needs a completely different use case, where a drone would be a really great example of being used to inspect oil rigs or being able to keep up with the shipping roads to keep them more secure and keep eyes on what's happening. So what I've found is different regions have different use cases that they're leading with, and in some cases it actually solves infrastructure rollout problems, and in other cases they're looking at, do I have all of the right endpoints and the right connections along the way for that infrastructure rollout?
I tend to agree with Lynn on this. I always think that there's a counterbalancing word for infrastructure, and that's innovation. When I think about the fact that there'll be 9 billion wireless subscriptions by 2023 and 20 billion connected devices, the opportunities for job creation and innovation in everything from gaming to education, because a lot of the fiber's already been laid and there is a sufficient demand because of how enterprises are transforming now, that the infrastructure always seems to catch up to innovation. We talked about electric cars forever, and now at my local train station in Connecticut, there are charging stations for your car. We built out the infrastructure because people wanted the innovation. I had the opportunity about 10 years ago, earlier in my career, to participate in a statewide distance learning program in New Mexico. New Mexico is a state where about 50% of the population lives in Albuquerque and 50% of the population lives everywhere else. And if you want to create educational opportunities for half of the K through 12 students in the state, then you are reliant on distance learning technologies because you have to bring the data to the end user. You have to bring the information to the kid. And I got to participate in this amazing story hour at 7 o'clock Mountain Time one night with a teacher and 25 7-year-olds from Roswell to Las Cruces to all over New Mexico. And you have these little kids in some of the poorest parts of New Mexico with netbooks and headsets reading along and listening to a teacher read this story. And so my belief is that the infrastructure always catches up to the innovation, and the innovation creates not just economic opportunity, but opportunity for companies to really live their purpose.
That is an excellent note to conclude on. Thank you, Eric, and a really nice image. Appreciate that. I appreciate all of you for sharing your expertise with us. And so thank you to our panel. Appreciate it.